Hi, in this video, I'm trying to understand the chemistry behind the chemical crisis going on in Garden Grove, California. That's actually less than 10 miles from my house. And I really want anyone who sees this video, but you know more chemistry than I do, to please jump in and supply any missing information or add any comments or correction or anything like that, please. I'm a math person and also something of a physics person, but I'm not that much of a chemistry person. So, yes, I really want to understand what's going on chemically because so far I have not seen any of those explanations. To summarize what's been going on in Garden Grove is that 3 days ago, on Thursday, May 21st, 2026, at the GKN Aerospace facilities in Garden Grove, there's a huge industrial storage tank, about 7,000 gallons, containing MMA. It started to overheat. And right now, as of right now, 3 days since the crisis started, they're still afraid that the tank may explode. So a chemical explosion in the middle of a residential area. So they've evacuated 40 to 50,000 people living around that area. And you know, some people end up with families, but those who don't end up with shelters. And there have been like numerous emergency shelters set up in the area, including one at my sister college, Golden West College. So I'm making this video based on my understanding of the chemistry behind the crisis. So if anyone knows more about chemistry, would you please add your comments or supply some more information, either in your knowledge of chemistry as a science or chemical engineering as an engineering field, please. The chemical that's in that 7,000 gallon tank is MMA, methyl methacrylate, and it is used to make plastic. Plastic is polymer, meaning it's a long chain of molecules. So MMA is one of those molecules that could be linked up together into a long chain. So it's called a monomer. The name methacrylate means it comes from methacrylic acid. So that means it's used to make acrylic plastic. And I've been told that it's something like a airplane window. So the military or civilian aircrafts are the customers of this company. By the way, in the old days, M&A was used on nail products, but it's supposed to be illegal in the US, but it's still legal in some other countries. So if you have your nails done in other countries, you may want to be careful because it's really harmful to your skin. But anyway, so here is the atomic structure of MMA. The key is this double bond from the H2C to the C. That's a double covalent bond. A covalent bond is where two atoms share their electrons. That's opposite of an ionic bond where one ion is positive and attracts the other ion that's negative. In the covalent bond, both parts are charged neutral, but they have electrons that want to pair up with other electrons. In this case, there are two pairs of electrons between the two carbon atoms. So there are a lot of electrons in a small space. That means if there are some free radicals that's looking for an electron, they'd be drawn to the electrons there. So suppose we have some free radical or dot. It will find this MMA and it will attack the double covalence bond. So it will break up one of the covalent bond and then it links up. So the result will be something like this. There will be a covalent bond here, a covalent bond here. That means the two electrons that used to be in this covalent bond, This one will go over there, so it's okay. But now this one is missing a partner. So now this C at the center here becomes a free radical. It will be going looking for someone to pair up with. That one will be another MMA molecule. This central C will find the MMA molecule. It'll break up this double covalence bond here and creates another unpaired valence electron in the central C of the second atom, and then repeat. And that's how you create a long chain of carbons. That's how you create the polymer, and you end up with the plastic. If you want to intentionally create the plastic, that's the reaction you're looking for. But if you're not trying to create one, then you don't want any of this to happen. Because if this happens in the wild and not under your control, then you have like a long string of carbon. And then it'll get all tangled up like spaghetti. That's the first thing that you don't want. And the other thing is this process is exothermic. That means it gives off heat. And this heat provides energy for even more polymerization to take place. And that's why you don't want random polymerization. Hard things that are tangled together is not something we want. In industry, you want the MMA to polymerize only under controlled conditions. When they are not being used, you don't want any of these reactions to take place. So to prevent MMA from polymerizing randomly, you put in some inhibitor. Now, the usual chemical that they use is called MEHQ. This is one of the things I don't have a lot of good understanding on. I don't have a lot of good understanding on what MEHQ is or the nature of what it does. I do understand how it helps with inhibiting polymerization. It doesn't do anything about the MMA itself, but what it does, it helps prevent these free radicals from messing with the MMA. Suppose we have some free radicals in the mix. And this could be, it could be this. It could be some polymer that's already forming that is now a free radical. Well, first of all, they actually also have oxygen in the tank. So suppose that we have some free radicals going around looking for another MMA to hook up to, then the oxygen, the O2, will find it first. There's a special structure of O2 in quantum chemistry, which I also don't understand very well, but I understand that because of it, the oxygen will catch the free radical faster than the free radical can find the MMA. The oxygen will react with the free radical, and it creates this where the electron here goes from the radical to the oxygen atom. Well, you may say, well, that doesn't help, right? Because this is now a free radical with oxygen. Well, but that's where the MEHQ comes in. You have the free radical with the oxygen. It reacts with the MEHQ. And first of all, it neutralizes the free radical. And then you end up with MEHQ that is also a radical. But the thing about MEHQ is that it has a ring structure. And since it has a ring structure, the electron kind of like gets stabilized inside that ring and won't react with the MMA. That's the stable, safe way to handle MMA. It requires two things. There must be enough MEHQ and oxygen in the tank to make sure that all of this happens. And the second thing is that the MEHQ and the oxygen in the tank must be mixed with the MMA. If something goes wrong in the tank, for example, there's not enough MEHQ, or there's not enough oxygen, or or the oxygen floats to the top, then that would be bad because none of this inhibiting reactions can happen. And then you end up with random polymerization up here. And the fact that the reaction is exothermic, that's where the whole heating up happens. That would be unsafe. So that's my understanding of what's happening in Gun Grove is somehow the whole inhibiting mechanism failed. And that's why we're in the problem we have today. And the whole heating of the tank comes from the polymerization process, which is exothermic, and it heats up the tank under high pressure, and that's where the risk of explosion comes from. So that's my understanding. But if you know more chemistry and if you know what's going on, please add your comments below. Thank you very much. Bye.